All right, moving on with our calculus theme and limits, we're going to talk about tangent lines, which is the core of just about everything calculus. A tangent line, best described with the picture. I'm not going to try to give you a definition of it, but if you have some graph, like right here, I give you some just generic f of x, a tangent line is simply a line that just touches the graph and sits on top of it. So that red line would be considered a tangent line. It intersects the graph at just that one point. And that one point is what we call the point of tangency. So the point of tangency is this point right here. So that is the point, I can't spell, point of tangency. That says tangency, whatever. There, good enough. This graph, or this line right here, is the tangent. And then we also have something called a secant. And a secant is simply a line that intersects the graph twice. So if I wanted to graph a secant would look something like this. It intersects the graph in more than one spot. It could intersect 3 times also. But this is a secant because it does cross the graph twice. So let's label that. This one's the secant. All right, so that's what a tangent is. And what we're going to try to do is find a way to get the exact slope of the tangent line. That's going to be our main challenge right here. And that's one of the first things you learn in calculus. And then you just use it over and over and over and over and over again, pretty much the whole year. So the way we're going to find a tangent line, I'm going to give you a specific example of one first, where I give you the graph of y equals x squared. That's our parabola. And I want the tangent at x equals 2. Well, here's x equals 2 right here. Here's the point of tangency, and I want to find the slope of this red line. Now I can look at it until it's pretty steep. That's a slope of maybe 4, 5, 6. It's a steep slope. But the way we're going to get the tangent slope is we're actually going to start with a secant. And let me show you what I mean by that. All right, here is a way we can kind of look at this. This is Geometry Sketchpad. And what I can do with this, actually I think kind of like it minimized. Okay. Or not minimized, whatever. All right, so this is our graph. This is x squared. And then we have our tangent right here. And the way I'm going to find the secant is by the slope of the tangent is by starting with a secant. Now, the way I create a secant is I simply pick a point somewhere else on the graph. It could be anywhere. I'm just going to say randomly I'll pick this point right here. And I'm going to draw a secant through the tangency point to that point. So let me do that real quick. So here comes a secant, and I'll just pick some other point on the graph. I'll pick it right here. And what we're going to do is look at this secant and that point, and I want to find the slope of that secant. And so let's start by finding the slope of the secant. And to find the slope of the secant, if you remember slope, your old-fashioned Algebra 1 slope is your change in y over change in x. So if I'm going to find the slope of the secant, I need an x and a y coordinate for both of these points. Now the first point, my point of tangency, is going to be pretty easy. If the graph is y equals x squared, and I know that x is equal to 2, then y equals 2 squared. I'll just plug in 2 for my x, and I know my tangent point is 2, 4. So I know that this ordered pair right here is 2, 4. What I don't know is this second point right here. This is some x coordinate that we're just not sure of. I don't know what it is, and so what I'm going to do is I'm going to make it something generic. I'm just going to call it x. And if this point is x, I also don't know the y coordinate, so I'm simply going to call it y. So I'm going to start with the slope of the secant, my secant slope. And I'm simply going to find the slope between these two ordered pairs. And again, we don't know this one, so I just called it something generic, x and y. I know the slope is my change in y, so I'm going to say y minus 4 over x minus 2, and that is the slope of the secant. And since I know that y is equal to x squared, I can actually take x squared and plug it in for y right here, and that would give me a secant slope of x squared minus 4 over x minus 2. So there is my secant slope. Now the thing is, we didn't want the secant, we want to ultimately find the slope of the tangent. So what I'm going to do to turn the secant into the tangent is I'm going to drag this point closer and closer to the point of tangency. All right, so here we are, and I want to turn this secant into the tangent. Now my secant is this blue graph right here. It's kind of hard to tell it's blue. I may make it a more vibrant blue. I'll make it green. There. Nah, that's too hard to see. Will that work? Try one more color. Purple. There we go. Pink. I don't know. All right, so to turn this secant into the tangent, I'm going to take this x coordinate right here, which we don't know what it is, and I'm going to move this x coordinate closer and closer to the point of tangency. And as I move this second point closer to 2, then the slope of the secant, as I keep moving closer to 2, the slope of the secant gets closer and closer to the slope of the tangent. As I get closer and closer, as my x gets close to 2, then the secant gets closer and closer to the tangent. And then eventually, my x is right on top of my 2, and bow, right there. The secant actually becomes the tangent. So we start with some secant, and then we move that x coordinate closer and closer and closer to 2. So as x approaches 2, the secant becomes the tangent. And I used a key word there. I used the word approach, and that was not an accident. What we're going to do to get the tangent slope, so to get this tangent slope, we're going to look at the secant slope, and we're going to analyze this slope right here. That's the secant slope. We're going to analyze that as x approaches 2. And we're going to work out this limit, the limit of the secant slope as the x point gets closer and closer to the 2 point. And your answer to that will be the answer to the slope of the secant, or the tangent. So we'll try plugging in 2 first. You will get 0 over 0, which means we need to factor. So this factor is x plus 2, x minus 2, over x minus 2. The x minus 2's cancel, leaving you with x plus 2. And then I can plug 2 in. 2 plus 2 is 4. And that is a reasonable slope. I think that red line has a steep slope, and 4 is about right. Actually, it's exactly right. So there is the very detailed way that we're going to sketch slopes, or find the slope of a tangent. We start with the secant, then we do the limit as x approaches the point of tangency of that secant slope. All right, so let's try another one. This one's going to be a little bit quicker because I did that first one very slowly. But hopefully you have at least a vague idea of what's going on. I'm going to graph x squared minus 4x. And the way I graph that, it is a parabola, x squared minus 4x. So I know it's a parabola that opens up. I'm going to find the roots. I'm going to factor out an x and set this thing equal to 0. And this thing has x-intercepts at 0 and 4. That's going to come in handy because now I can graph a parabola that opens up with x-intercepts of 0 and 4. There we go. So parabola that opens up with x-intercepts of 0 and 4. So that's what I have here. And then my point of tangency is x equals 3. Well, this is 3 right here. So my tangent is going to be down here on the graph when x is equal to 3. So I have a slope that's going to be somewhere, or a tangent that's going to be somewhere like that. And I want to find the slope of that tangent. First thing I'm going to do very quickly, because it's easy, is I'm going to find the y-coordinate that goes with my point of tangency. So my y-coordinate is going to be 3 squared minus 4 times 3, which 9 minus 12 is negative 3. So we have the ordered pair 3, negative 3. And then to kind of give myself a visual, I draw my secant slope, or my secant, and my secant could go anywhere. I'll draw it right there. What the heck? So there's my secant. And then I have this other point that I don't know. We just called this point x, y. And I start with the secant slope. So my secant is going to be a slope of y minus y, so y minus negative 3 over x coordinate minus x coordinate, which is x minus 3. But I do know that y is equal to x squared minus 4x. So I'm actually going to plug that in for y right there. So this is going to turn into x squared minus 4x, that's my y, minus the negative 3, which is plus 3, over x minus 3. Okay, that's my secant slope. But again, I don't care what the secant slope is. I want to know what the tangent slope is. And the way we turn the secant into the tangent is we look at the secant slope, and we want to know what happens as the x coordinate gets closer and closer to 3. And there's your tangent. So my tangent slope is going to be the limit as x approaches 3 of my secant formula, so x squared minus 4x plus 3 over x minus 3. And then we will factor, and then we'll plug in 3. So this factors to x minus 3, x minus 1 over x minus 3. The x minus 3's cancel, leaving you with only x minus 1. And then I can plug in 3. 3 minus 1 is 2. That is the slope of the tangent. And 2 is a reasonable slope. I should get something positive. And I kind of like a slope of 2 for that red line. So there we go. There's a slope of a tangent. Start with the secant and do the limit of that secant as x approaches the point of tangency. A general formula you could follow, and this is kind of what we've been doing, this is the formula we use for the slope of that tangent. So we could, and I'm perfectly okay, and I actually would rather you jump straight to this limit to get our slope of a tangent, rather than going through and graphing it and drawing the secant and doing all of that. I would prefer you just to jump straight to the formula. So here's the general formula. The tangent to a function at any point x equals a is this limit. The limit as x approaches the point of tangency, f of x minus f of a over x minus a. So let's do that with this problem, number 3. I didn't say f of x equals, I said y equals, but that is your function, f of x. And I know my formula is going to need f of a, and in this case, a is equal to 1. So I'm going to find f of 1, which is 1 cubed plus 2 times 1 minus 1, and that cleans up to just 2. So f of 1 equals 2. And then I'm going to go straight to my formula for the tangent slope. So my tangent slope is going to be the limit as x approaches the point of tangency of my function, f of x, which is x cubed plus 2x minus 1. There's f of x minus f of 1, which is 2. So that's f of x minus f of 1 over x minus 1. And then we start cleaning that up. So f of x minus f of 1, that turns into x cubed plus 2x. Minus 1 minus 2 is negative 3 over x minus 1. And you have to be very careful here because you want to factor, but this is an x cubed. It's not an x squared. That means this one's not going to factor well. If it was x squared minus plus 2x minus 3, then that would be nice and we could work with that. But x cubed plus 2x minus 3 is not going to factor. So I hope we could just plug in. So let me try plugging in 1 and see what happens. 1 cubed is 1 plus 2 times 1, which is 2 minus 3 over 1 minus 1. And you do get 0 over 0. By the way, if you set up the limit problem correctly, the tangent problem correctly, you will always get 0 over 0. You will get that indeterminate form when you first plug in. So we do need to cancel in some way, but the problem is this doesn't factor. Since this doesn't factor, we have to clean this up through either long division or synthetic division. And I know that sounds evil. Synthetic division is really not that bad. So synthetic division, I have this thing divided by x minus 1. So I'll put plus 1. I'm divided by x minus 1, so we put a positive 1 out there. It's 1x cubed, 0x squared, 2x, and a negative 3. And then we'll bring down the 1, and we do synthetic division. 1 times 1 is 1, 0 plus 1. 1 times 1, 2 plus 1 is 3. 1 times 3 is 3, and you should get a remainder of 0. And I'm left with 1x squared plus 1x plus 3. And that's what this will cancel to. So I'm left with x squared plus x plus 3. And when I plug 1 into that, 1 squared is 1 plus 1 for x plus 3, and you get a slope of 5. Good? Good, 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 good. All right, so we get a slope of 5. And then one other thing that I have in here that's going to that's a little bit different than the other problems is I asked for the entire equation of the tangent line. I want the entire equation. On the previous problems, I only wanted the slope. If you want the entire equation, I prefer point slope form. If I ever ask for an equation, you will need a point and a slope. Well, we just found the slope. We know that the slope of the tangent line is 5. We also need a point, but we actually found the point right here. This is the point. When I plugged in 1 for x, I got a y coordinate of 2. So that's my point of 1, 2. And then if you have a slope and a point, you take both of those things and you roll it into point slope form, which we have talked about point slope form before. So we take the point and we take the slope and we roll those into point slope form, which is y minus the y coordinate equals your slope times x minus the x coordinate. And there is the equation of the entire tangent line. So you have the slope and the point. You throw it in point slope form. And there we go. So that is tangent lines. There was more I wanted to do, but this is already 16 minutes long, which is enough. See y'all later.